Hello, welcome to my channel. Max 2A, Chapter 1, Exercise 1A. First Roman, first question. If Z1 is equals to 2, minus 1 and Z2 6, 3, find Z1 minus Z2. So first we will write what is given. Given Z1 is equals to 2, minus 1 and Z2 is equals to 6, 3. First we will convert Z1 and Z2 in the form of complex number, that is in the form of x plus iy. So if we convert this, we get Z1 is equals to 2 minus 1i, and if we convert this, we get 6 plus 3i. Now we need to find Z1 minus Z2. So we will consider this complex number forms. Z1 minus Z2, so 2 minus i minus of 6 plus 3i, which is equals to 2 minus i minus 6 minus of plus is minus 3i. Subtracting, we get minus 4 minus 4i. So this is Z1 minus Z2. As the question was given in form of points, we will write the answer to in the form of points only. Therefore Z1 minus Z2 is minus 4, minus 4. This is the answer. Now second sum. Given Z1 and Z2, we need to find Z1 into Z2. Consider given Z1 is equals to 3, 5. Therefore in the form of complex number, we can write it as 3 plus 5i. Given Z2 is equals to 2, 6. Therefore in the form of complex number, we write it as 2 plus 6i. Now we need to find Z1 into Z2. Therefore Z1 is 3 plus 5i into Z2 2 plus 6i. Multiplying, 3 2s are 6 plus 18i plus 10i plus 30i square. We know I square is equals to minus 1 since. So first 6, adding these both terms, we get 28i. As I square value is minus 1, substituting, we get plus 30 into minus 1. Therefore 60 plus 28i minus 30 equals to minus 24 plus 28i. As the question is given in the form of points, we will write the answer in terms of points only. Therefore Z1 into Z2 is equals to minus 24, 28 is the answer. Third bit, write the additive inverse of the following complex numbers. So we need to find the additive inverse of the given complex numbers. Let's find it out. Given z is equals to root 3, 5, writing it in the other form, we get root 3 plus 5i. Additive inverse is nothing but minus of z. So minus of root 3 plus 5i, which is equals to minus root 3 minus 5i. This is the additive inverse. As the question is given in points, we will write in the term of points only. Therefore additive inverse, that is minus z, is equals to minus root 3, minus 5. Now second one, given z is equals to minus 6, 5 plus 10, minus 4. Converting both of this, we get minus 6 plus 5i plus 10 minus 4i. when we solve, we get it as 4 plus I. Therefore, additive inverse minus z is equals to minus of 4 plus I, which is equals to minus 4 minus I. Therefore, additive inverse of the given question is minus 4 comma minus 1. Similarly, third question, given z is equals to 2 comma 1 into minus 4 comma 6. We can write it as 2 plus I into minus 4 plus 6I. Multiplying each term, we get minus 8 plus 12I minus 4I plus 6I square. Since I square is equals to minus 1, minus 8 plus 12I minus 4I is 8I plus 6 into minus 1, minus 8 plus 8I minus 6, which is equals to minus 14 plus 8I. Therefore, this is z. Therefore, minus z is equals to minus of minus 14 plus 8I, which is equals to 14 minus 8I. Therefore, the additive inverse is minus z equals to 14 comma minus 8. Second Roman, first problem, given z1 and z2, we need to find z1 by z2, that is divided by. Given z1 is equals to 6 comma 3, this can be written as 6 plus 3I. Similarly, z2 is given, which is 2 comma minus 1, and this can be written as 2 minus I. Now we need to find z1 by z2, which equals to 6 plus 3I, z1 by z2, which is equals to 6 plus 3I by 2 minus I. Now rationalizing this with the denominator, as the denominator is also in the complex number form, that's the reason we are rationalizing here. So if we rationalize here, 6 plus 3I into 2 plus I we will get by 2 minus I into 2 plus I. We get it as 12 plus 6I plus 6I plus 3I square by, this is a plus b into a minus b form, which is nothing but a square plus b square, a square minus b square, therefore 2 square minus I square, which is equals to 12 plus 12I minus 3 by 4 minus of minus 1, since I square is equals to minus 1. Therefore, 9 plus 12I by 4 plus 1 will get, which is equals to 9 plus 12I by 5. Now writing it separately, z1 by z2 is equals to 9 by 5 plus 12 by 5I. This is the answer. As the question is given in the form of points, we will write in the form of points, that is 9 by 5 comma 12 by 5. This is the final answer. Now second problem, this is an important problem for 2 marks. Let's do this question. Given, we will write first z is equals to cos theta comma sin theta. We need to find z minus 1 by z. So first from here we'll convert this into cos theta plus I sin theta. This is what is the value of z. Now as we need 1 by z for solving the problem, we will find 1 by z first, which is equals to 1 by cos theta plus I sin theta. Denominator has a complex number, therefore we will rationalize. If we rationalize, we get 1 into cos theta minus I sin theta by cos theta plus I sin theta into cos theta minus I sin theta which is equals to cos theta minus I sin theta by, this is cos theta plus I sin theta into cos theta minus I sin theta, that is in the form of a plus b into a minus b, which is nothing but a square minus b square. Therefore cos square theta minus I sin theta whole square will get, so this will be cos theta minus I sin theta by cos square theta minus I square sin square theta, which will be equals to cos theta minus I sin theta by cos square theta plus sin square theta, since I square is equals to minus 1. We know that cos square theta plus sin square theta is equals to 1. Therefore this value is 1. So we get cos theta minus I sin theta as the value of 1 by z. Now consider z minus 1 by z. Substituting z, which is nothing but cos theta plus I sin theta minus 1 by z value, that is cos theta minus I sin theta, which is equals to cos theta plus I sin theta minus cos theta, minus of minus is plus, so plus I sin theta. These can be cancelled, so at the end we get the answer as 2I sin theta. Therefore here the real part of the complex number is 0. Therefore z minus 1 by z is equals to 0, 2 sin theta. This is the answer. Now third bit, write the multiplicative inverse of the following complex number. Multiplicative inverse is nothing but 1 by z. So we will solve the first one now, that is 3, 4. Now given is z is equals to 3, 4. We can write it as 3 plus 4i. So we need to find the multiplicative inverse, which is nothing but 1 by z, equals to 1 by 3 plus multiplicative inverse 1 by z is equals to 1 by 3 plus 4i. Rationalizing it, because we have a complex number in the denominator, we will rationalize. So we'll get 1 by 3 plus 4i. If you rationalize it, we get it as 1 into 3 minus 4i. Similarly in the denominator, 3 plus 4i into 3 minus 4i, we get it as 3 minus 4i by a plus b into a minus b. Therefore a square minus b square, 3 square minus 4i square, which is equal 3 minus 4i by 9 minus 16i square. Since I square is equals to minus 1, we get it as 3 minus 4i by 9 plus 16, which is equals to 3 minus 4i by 25. We'll write it as 3 by 25 minus 4i by 25. Therefore the multiplicative inverse of the given question is 3 by 25 comma minus 4 by 25. Now we will solve the second question, that is given complex number is sin theta comma cos theta. We have here z is equals to sin theta comma cos theta. This is given. We are writing this in the form of sin theta plus I cos theta. Then we multiplicative inverse is 1 by z, which is equals to 1 by sin theta plus cos theta I, which is nothing but I cos theta only. Rationalizing it with the denominator, we will get it as 1 into sin theta minus I cos theta, sin theta plus cos theta into sin theta minus cos theta I, which is equals to sin theta minus cos theta I by sin square theta plus cos square theta. Since I square is minus 1, when we write cos square sin square theta minus cos square theta I square, we get this form, that is sin square theta plus cos square theta, whose value is 1. Therefore we get the answer as sin theta minus cos theta I Therefore, the multiplicative inverse of the given complex number is sin theta, comma, minus cos theta. Now third question, complex number given is 7, 24. Given z is equals to 7, 24, we are writing it in the form of x plus iy, that is z is equals to 7 plus 24i. Now multiplicative inverse 1 by z is equals to 1 by 7 plus 24i. We have to rationalize it because the denominator consists of a complex number. When rationalized, we get 1 into 7 minus 24i by 7 plus 24i into 7 minus 24i, which is equals to 7 minus 24i by 7 square, which is 49, minus 24i whole square, which is 576i square. Since I square is equals to minus 1, we get it as 7 minus 24i by 49 plus 576. 49 plus 576 is nothing but 625. Therefore, we get the answer as 7 minus 24i by 625. Separating and writing, we get it as 7 by 625 minus 24 by 625i. Writing in the form of points, we get the multiplicative inverse as 7 by 625, comma, 24 by minus 24 by 625. This is the answer.